Okay, this is another rectilinear motion problem, calculator active. Particle moves along the x-axis so that its velocity is given by this function, and at time 0 the particle is at position 1, so it's starting at position 1, not at the origin. Find the acceleration of the particle at time 2. Acceleration is the derivative of that, so listen, that looks kind of messy, so I'm not going to actually find that derivative since we're allowed to use our calculator. I'm going to use it. I want the acceleration, or in other words, the derivative of velocity at 2. So that's math 8, and my derivative is negative x plus 1 times the sine of x squared over 2. That looks good. Comma x, comma 2. I want finding the derivative at 2. That's 1.586. Sorry, 1.588. Excuse me. And we should probably say, like, that's the derivative of velocity at 2. That's how we found that. Okay? Is the speed of the particle increasing? Well, its speed is increasing. That means speeding up if the velocity is also positive. The acceleration was positive, so let's find the velocity at 2. That's just plugging 2 into this, right? So that would be, just calculate that. Plugging 2 into the velocity function. All we care really about is its sign. Plugging 2 in here, that would be negative 3 times the sine of 2 squared over 2, which is negative. Doesn't really matter what the number is, but there it is, so I might as well write it down. So the answer is no. Is the speed increasing? No. Speed is decreasing because acceleration at 2 is positive and the velocity at 2 is negative. That's all you need for your justifications, right? Why or why not? That's why. Or why not, I guess. Okay, part B. Find all times t when the particle changes direction. The particle changes direction when the velocity is equal to 0. So, direction, let's just justify first. Direction changes when velocity is 0. Actually, that's not entirely true, right? Because the velocity could like dip down and hit 0, and then it could keep going in the same direction. So I should say when velocity goes positive to negative, or negative to positive. Or you could say when it changes sign. So let's graph the velocity and see when that happens. So velocity function is negative x plus 1 times the sine of x squared over 2. And the window we only care about from 0 to 3. 0 to 3. And I'll leave those y values, see if how that looks. Not too great. I think we probably want a better look at that, so let's go from, well, how about negative 4 to 4? Just check out, make sure nothing's happening there. Negative 4 to 4. So it looks like that's the only value there where it changes sign. So second calculate, let's find that 0. You can just type in the values, right? Or you can play this game with the cursor. 2.507. Right? So in fact, just to say a little bit more about that, the particle would be moving to the left and then to the right. These are negative velocities and then positive velocities. Okay, part C. Find the total distance traveled from 0 to 3. Hey, look, I have the velocity graph right here, so all I need to do to find total distance traveled is throw some absolute value signs around that. Graph it again. So all that stuff that was negative is now positive, and then bounce. And find the area under that, which will give us the total distance traveled from 0 to 3. Wait for the little calculator to think. And it shades in the area for us. And it looks like the total distance traveled is 4.338. This is the integral from 0 to 3, the absolute value of the velocity function. You should write this down, absolutely. That might be worth one of the points. And I'm just going to look here. This would have, they didn't say anything about units, meters, and seconds, so if they don't say anything about units, you don't need any. Okay, last part. During the time interval from 0 to 3, what's the greatest distance between the particle and the origin? And show your work that leads to your answer. All right, well, let's go back to the velocity graph. In other words, let's get rid of the absolute values. And look at that again. Oops. That looks upside down. Oh, that's because I lost my negative sign. There we go. That looked funny. Okay, now I have to think about this carefully. The particle starts at time 0, it's at 1, right? So it starts out at position 1, and then it moves in the negative direction for quite a while, and then it moves in the positive direction for a while. So I think I need to find the position at a few places. The only possible places that could be the furthest from the origin are places where it changes direction or the endpoints of the interval. Okay? It's not a closed interval, so we need to check those endpoints too. So we're going to find the position. Do they give that as, well, I'll call it x. So the position at 0 is 1. The position at the other places we have to check are 3, which we'll do in a minute, and then the wherever it crosses here. Did we find that already? We did. It changes direction at 2.507. So where is it at 2.507? Well, we need to find that displacement. So the displacement from 0 to 2.507 is the area under the velocity curve. And let's see, that's, I'm going to go from 0 to 2.5007. Okay, so the displacement is negative 3.265. Negative 3.265. And remember, that's equal to, that's the position at, 2.507 minus the position at x sub 0. And we know that the position here is 1. So in fact, even though the displacement was negative 3.3 and change in this direction, it started at 1, right? So it's actually negative 2.625, right? Because of this. This is equal to 1, so I'd have to add that over there, right? It matters where it starts. It didn't start at 0. This is the displacement. Displaced from where? Displaced negative 3.265 to the left. Negative 3.625 from 1, right? And the negative means to the left. So here are the positions so far. Where is it furthest from the origin? Well, here it's 1 from the origin. Here it's negative 2 and change from the origin, so that's winning so far. And then finally, I need to find the position at 3, just to make sure that somehow it didn't get further. So I can do the same thing. Let's find the displacement. I don't care about total distance traveled here. I actually want to know where it is, right? So that's displacement. So second, calculate integral again, this time from 0 to 3. That's negative 2.197. And that would be the position at 3 minus the position at 0. That's going to be a 1 again. So adding the 1 over here, it is still to the left of the origin, but not as far as this. So what's the greatest distance between the particle and the origin? It's this. And to get full credit, I think you probably need to, I can check the rubric, but I think you probably need to show that you found the position at all 3 of these points, including this endpoint, right? If you thought, if you thought just looking at the graph that it looks like it would have moved further here, you're right, but you have to justify that, showing that work. All right. Last one. I might need some extra paper for this. Don't have a lot of room there. All right. So let's see what we have here. Particle moves along the x-axis with a velocity at times greater than 0, given by this velocity function. This is a no calculator problem. Find the acceleration of the particle at time 3. So the acceleration is the derivative of velocity. So the derivative of the velocity is, the derivative of negative 1 is 0. The derivative of e to the whatever is e to the whatever times the derivative of what's inside. Derivative of that is just negative 1. So that means the acceleration at 3 is equal to 3 plugged into that. That would be e to the 1 minus 3. It's e to the negative 2 times negative 1. That would be negative e to the negative 2. Okay. And we can't give a numerical equivalent or decimal approximation of that because we are not allowed to use our calculator on this problem. Is the speed of the particle increasing at time 3? Give a reason. Well, we know that the acceleration is negative. Acceleration at 3 is negative. How about the velocity at 3? The velocity at 3 would be negative 1 plus e to the 1 minus 3. That's e to the negative 2. Now you're wondering, is that positive or negative? Well, let's think about that. That's negative 1 plus 1 over e squared. And e is like 3-ish, so negative 1 plus 1/9 is negative. So the velocity at 3 is also negative. So acceleration is negative, velocity is negative, so the speed of the particle is increasing. Yes, it's speeding up because acceleration is greater than is less than 0, and velocity is less than 0. And if they have the same sign, then you're speeding up. You're just speeding up in the negative direction. Okay, part C. Find all values of t at which the particle changes direction. Justify your answer. Let's justify first. Direction changes when velocity changes sign, right? From positive to negative or negative to positive. So let's see if we can find out where that happens. So let's set the velocity equal to 0. Negative 1 is e to the 1 minus t. So let's see, it's 1 equals e to the 1 minus t. And if we take the natural log of both sides of that, natural log 1 equals natural log of e to the 1 minus t. Natural log of 1 is 0. The natural log of e to the whatever is just natural log and e cancel out. It's 1 minus t. So t equals 1. And then we just have to show that for sure it changes sign there. So here's 0, here's 3, here's 1. So we do have to test a couple values in here. Let's test a value in the velocity function here. So in here, the velocity would be, let's plug in like 1/2. Negative 1 plus e to the 1 minus 1/2. That would be the e to the 1/2. So the square root of e. Now e is like 3-ish. So the square root of 3 is somewhere in between 1 and 2, right? So negative 1 plus a number that's between 1 and 2 is positive. And then if I plug in a number like 2, you get negative 1 plus e to the 1 minus 2. 1 minus 2 is negative 1. E to the negative 1 is about 1/3. So negative 1 plus 1/3, that's negative. So, yes. So, let's see. Find all values of t. T equals 1. And this is the justification right here. E of t goes positive to negative. Right, just showing that it's equal to 0 isn't enough because it could be like positive, positive, or negative, negative. You actually have to show that it does change sign. And without a calculator, you've got to do the sign chart. Okay, last, find the total distance traveled by the particle over the time interval from 0 to 3. Well, we don't have our calculator this time, so that means we've got to actually do this by hand. So let's see if we can do it. We need to find, we want only positive distances that it traveled. So can we do it? We want to find, let's see, from 0 to 1 it was going in the positive direction. So can we find the displacement from 0 to 1? And then let's find the displacement also from 1 to 3. And then we'll just make sure everything's positive and add up those total distances. So that is the integral from 0 to 1 under where'd my velocity function go? It's negative 1 plus e to the 1 minus t dt. The antiderivative of negative 1 is negative t. The antiderivative of e to the 1 minus t is e to the 1 minus t. And if you do a u substitution, it's just a negative sign that's going to pop out. You can work through that if you want to. But your du would just be negative dt, and that would pop a negative sign out. So that's what's happening there. And that gives us negative 1 minus e to the 1 minus 1, that's e to the 0, minus 0 minus e to the 1, so that gives us negative 1, e to the 0 is 1, negative 2 plus e, And that's a positive number, right, because e is bigger than 2. So there's some positive distance that it traveled. Now we also need to find the distance from 1 to 3. But since we know it's going in the negative direction, there's a couple ways you can deal with this. I'm going to be sneaky and say, since I want it to be a positive distance, I'm going to just switch those numbers, because then I know it will make it positive. You don't have to do that. You could just do 1 to 3, and then at the end make sure it's positive. Just take the absolute value. But I know it's going to be negative from part C, so I'm going to do that. Nice thing is we already have the antiderivative, so negative t minus e to the 1 minus t, 3 to 1. And I also know what you get when you plug 1 in. You get negative 2, right? That's what we just did here. Minus what you get when you plug 3 in, negative 3 minus e to the negative 2, right? That's equal to, let's see, negative 2 plus 3 is 1 plus e to the negative 2. So it traveled this far in the forward direction from 0 to 1, and then it traveled this far in the negative direction from 1 to 3. So the total distance traveled is negative 2 plus 1 plus e to the negative 2. There's your total distance. Not super fun without a calculator, but you can do it. You just have to break up those intervals. We already found where it turned around, so they kind of prepped us for that. Alrighty.